In this lesson, we're looking at our fourth type of transformation, dilations, and we'll be working on pages 16 to 18 in the Algebra 1 Summer Math Packet. Okay. Dilation is our final type of transformation we're looking at. And the first thing to really make sure we understand is the fact that dilations are not isometries or rigid motions because it's changing the size of a figure. Okay, so dilation is a transformation that produces an image that is the same shape as the original, but it is a different size. So it'll either be smaller or bigger. Okay. So a dilation is a scaling of the original and is not an isometry. Okay. In middle school, all of the dilations we look at are centered around the origin. In high school, you'll look at dilations that are centered around a different point. Okay. And the same with rotations also. Our dilation is based on a scale factor, and that scale factor is a ratio. We use K, right? You remember in 7th grade, you talked about your constant proportionality, your scale factor. It's that ratio of the image length to the pre-image length or a pre-image coordinate, okay? Like we said, is a ratio. If the scale factor is greater than 1, the figure is going to become bigger. If the scale factor is between 0 and 1, the figure is going to become smaller. So the way we look at that is xy becomes kx, ky, where k is the scale factor, and we're multiplying that to our coordinates. And that's how we're getting that increase or decrease in size. We could also see a dilation in that transformation notation like that, which would give us the scale factor to multiply by. Okay. So here we're going to graph and label triangle JOY. So let's start by just graphing it. Right? J is 1, 0. We'll go from there. Here we have triangle JOY, our pre-image. Now for our image, we're going to be using a dilation with a scale factor of 2. So the fact that that number is bigger than 1, I know it's going to make our figure bigger. So I would use that rule that we're multiplying by 2 to find the coordinates of our image and then plot. So 1, 0, that's just multiplying by 2. And then we can plot. So J prime is going to be 2, 0. And there we have our image, J prime, O prime, Y prime. At this point, students often ask why the triangle J prime, O prime, Y prime isn't centered around the original. And the reason for that is because the center of our dilation is the origin, not the center of the figure. In high school, you'll do work where the dilation is at the center of the figure, and that's where you'll see it perfectly overlap. But we only see what we think of as that perfect overlap when the figure is over the origin, which we see in example 2, where we see the image, the pre-image is over the origin and the image over the origin, and we get that kind of satisfying scaling. Okay. So the other question we could be asked for a dilation is to identify the scale factor or the dilation itself. So we want to remember that our scale factor K is a ratio of the image to the pre-image. So I want to choose a point to use. Like maybe I'll use point F, okay, and F prime. So I'll get the coordinates of F, -6, -3. F prime, -2, -1. And I'm just going to use one of those coordinates, either the X or the Y, to determine that scale factor to make that ratio. Now, if I had chosen points D or E, where one of the coordinates was 0 for both, then that would make the decision for me. I would use the non-zero coordinate. But here, I'm just going to use the X coordinate. Now remember, it's image over pre-image. So the image is F prime. So I'm going to put -2 in the numerator. I'm going to put F, the image, -6 in the denominator. So we have -2 over -6, which is a fraction that reduces to 1/3. So we can see that our scale factor is 1/3. And we can use K to represent that. We could write the scale factor is 1/3 if we were asked to write that using coordinate notation. Right? We would do that. Or write the dilation, we would use that notation. Okay, but that would depend upon the question. Okay. So as we work, we're going to see some graphing. We'll see some just sort of like finding the new points after a dilation.